In this video, we're going to evaluate the integral of x to the third over 1 plus x squared, quantity squared, using the substitution x equal tangent of theta. Now, this is the same integral that I did in a previous video where I used integration by parts. And I'll link that video in the description in case you want to refer to that. Here was my setup using integration by parts. The formula is right there in red. Integral of u dv equals to the product of u and v minus the integral of v du. And this was the setup. And again, the link to that video will be in the description. This is a substitution I'm going to use for this one, but let me give you the answer. This is the answer we got, or that I got, using integration by parts. And the part that's in red there, this is the answer that we'll get today using the trig substitution. Again, the part in red matches this over here, and the other part doesn't. Notice here I have 1/2, or 1/2 times 1 over 1 plus x squared, and over here I have minus 1/2 times this quotient of x squared over 1 plus x squared. They both work, and I'll show you how we can convert one to the other so you can make sure that it is the correct answer. So here's my substitution then. X is equal to tangent of theta. So this means that tangent of theta is equal to x, or x over 1. So tangent of theta is the opposite over the adjacent. We'll be using a triangle to complete the problem. Dx, of course, is the derivative of tangent, secant squared, theta d theta. And then the 1 plus x squared. So what I'm going to do now is transform this integral in terms of theta. So I don't want any x involved. I want everything in terms of theta or d theta. So notice we'll have an x right here. In other words, I'm looking at the denominator first. 1 plus x squared, quantity squared. And x is tangent of theta, so let's transform that part. Put a tangent of theta here where the x is. That gives me the tangent squared of theta. Or I should say 1 plus tangent squared of theta. Using one of your basic identities from Trig is secant squared. So 1 plus tangent squared theta is secant squared, and then we're squaring that. So I get secant to the 4th. So now we just transform this. This is equal to then x to the 3rd on top. That's going to be tangent. So that'll be tangent to the 3rd of theta. So just replace the x by tangent theta, then we're cubing it. And then remember the denominator right here. We showed that that's equal to secant to the 4th. So the denominator is replaced by secant to the 4th theta. And then the dx is replaced by secant squared theta d theta. So secant squared here replaces 2 factors of secant squared in the denominator, so this becomes a 2 then. And then this is equal to, and remember that tangent to the 3rd theta is the same thing as sine cubed theta over cosine, because tangent is sine over cosine. And the denominator we're going to have secant squared theta, okay? But secant and cosine are reciprocals, so I can multiply. So what I'm going to do here, I got secant squared theta in the bottom, so I'm going to multiply that by cosine squared theta. And so since secant and cosine are reciprocals, that goes to 1. And then in the numerator, I'm going to multiply also by cosine squared theta. Otherwise it's not legal. And then in the numerator, we have sine to the 3rd over cosine to the 3rd. So reduce that also to sine to the 3rd theta over cosine theta. And I still have the d theta. So again, I multiply the numerator and denominator by cosine squared, and the tangent is sine over cosine, so it'd be sine cube over cosine cube. Reduce it down, and it reduces to this. Now I know that the derivative of cosine is a minus sine, so I can break this up, use a trig substitution here. So I'm going to break the sine up into sine squared, the sine cube I should say, sine cube theta would be broken down into sine squared and sine theta. So sine cube be sine squared and sine theta. About the sine squared though, I'm going to replace that by 1. Use minus cosine squared. And I got a theta right there. Still got the cosine in the bottom over here. And I got the d theta here. So cosine of theta, derivative of cosine of theta is minus sine. So what I'm going to do then, the rest of the way then, it's going to be a u substitution. I'm going to let u equal to cosine theta, then du. Derivative of cosine is minus sine theta, d theta. Okay, so this is what we have then. U is cosine theta, so I'm going to go up here now, equals to minus, or the sine theta d theta. If I multiply both sides by a negative here, the right side will be positive then. This will be a minus over here. So here's what we have then. This part right here, 1 minus cosine squared, remember that's squared there, and the cosine is u, so I can write this in the numerator, 1 minus u squared. Denominator have cosine, that's u though. And like I said, the d theta, sine, that is sine d theta, would be minus du. So I'm going to put the minus out here, and this will be a du here. Take this out here. So now, got everything in terms of u. Let's simplify this, multiply through by the negative here. So this will be a minus, divide through by the u, you get this. Minus minus, this will be a plus. Reduce that to u. Now we integrate with respect to u. So this is actually two integrals here. So it'd be minus 1 over u du. So du over u, yes, that's your natural log here. So this will be minus natural log of absolute u. But we got to go back to the original variable anyway, so dealing with cosine theta, so this is cosine theta. Well, actually, this is not the original variable yet, because we started with x, but we still got to go to the theta first. And then integral here will be add 2 to the, or add 1 to the numerator here, 1 and 1, it's 2. And divide by that, so it'll be u squared over 2. But remember, u is cosine of theta. So instead of putting u squared over 2 here, I'm going to put cosine squared theta over 2. And then it's plus the constant of integration. Now that's the integration. That's the integration in terms of theta. But now we have to go to the original variable. So let's suppose this is theta here. And we have tangent of theta is equal to x. That means this should be x. Opposite side is x. And the adjacent side is 1. And the hypotenuse is the square root of 1 plus x squared. So this is equal to then, minus the natural log. And go back to the variable x. So minus natural log and the cosine of theta, go to the triangle. Cosine is 1 over adjacent side over the hypotenuse. So this will be 1 over the square root of 1 plus x squared. Don't need the absolute values, that's not negative there. And then we got a plus here. We got cosine of theta, quantity squared. Cosine of theta, the adjacent over the hypotenuse here. And then that's squared. Cosine theta is 1 over the square root of 1 plus x squared. But then you're squaring that, so that'll be 1 over 1 plus x squared. This times 1/2. So you could actually say this is the answer. We have minus the natural log of, don't need absolute values, but we can put it this in parentheses here. Natural log of 1 over the square root of 1 plus x squared. And from this right here, we have 1/2. 1/2 times 1 over 1 plus x squared. And then we have the constant of integration. So we have that. This could be an answer. Now let's get it closer to the answer we got using the integration by parts here though. But if you were just looking for the solution or the integral of this problem, you could leave it actually this way. But what I'm going to do here, I'm going to take this right here. Look at that first. That'll be minus, and then it's the natural log. It's a fraction, so let's use properties of logs. This is the same thing as the log of the numerator, which is 1, minus the log of the denominator. And I'm going to write that as, instead of the square root, I write that as 1 plus x squared to the 1/2 power. And then we multiply by this negative here. So this will become a plus. And this doesn't matter because the log of 1, natural log of anything, the natural log of 1, or the log of 1 but to any base is 0. So this could be 0 here. So this gives me then ln. And now again, properties of logs, I can bring this 1/2 to the front. So this will be 1/2. Natural log of 1 plus x squared. Don't need absolute values again because 1 plus x squared is not negative. So we got this answer here. So in place of this right here, this part minus ln of 1 over this, we can write it this way. And I still have the 1/2 of 1 over 1 plus x squared plus the constant of integration. So the only difference in this answer, again, whether you give this answer here, which is correct, simplified it to this, that's also the answer. And if we did it the other way, so using the integration by parts, we got the minus 1/2 x squared, 1 plus. One that did match, and the other one, it had this minus 1/2, and it was x squared over 1 plus x squared. This part was the same. These are the ones that were different. And again, the problem's been worked out. All I'm doing here is just showing you how you can justify that they're the same answer. So let's take this part right here and do a long division. This is a part that went with the integration by parts. Let's divide x squared divided by the denominator x squared plus 1. Long division. So x squared into x squared is 1. 1 times x squared is x squared. 1 times 1 is 1. Subtract, this cancels, so it gives me a minus 1 for remainder. So this entry right here, that entry right there, I can rewrite that as remainder is minus 1. It's the quotient first though. So it's the quotient 1, and then plus the remainder. The remainder is over the divisor, which is 1 plus x squared. So this replaces this part. And I want to get this. What am I going to have? If I multiply, remember, you still have the minus 1/2 also. So minus 1/2 multiplies the 1, which gives me a minus 1/2. But remember, we have a constant here. We could always put constants together. So, okay, the minus 1/2 goes with this one. What's left? Now I have minus 1 over 1 plus x squared. But remember, that's multiplied by a negative 1. So the negative cancels this negative, gives me a 1 over 1 plus x squared. And of course I have the 1/2. Same thing as that. Again, just trying to justify to you that they are the same answer. Thanks for watching. We'll see you next time.